Hello everyone, welcome to my GCSE chemistry revision class based on hydrogen fuel cells. So firstly, I'm just going to go through this diagram with you to begin with, and then I will shortly move over to the half equations and then the advantages and disadvantages, and followed by some exam questions. This is one of my predicted topics for the GCSE 2025 exams for the triple chemistry paper for AQA. Okay, so let's get started. So let me interpret this diagram with you to begin with. Now, just remember that here we have the anode and then we have the cathode. Now, both these electrodes are separated by the electrolyte, which is covered in grey over here. So this here, I'm just going to shade it in. This is where we have the electrolyte, where I've coloured it in purple. So an anode and the cathode are separated by the electrolyte. And the anode this time is the negative electrode and the cathode is the positive electrode, okay? Right, so let me explain to you what is going on in this diagram over here. So what's happening first is that the cell, it will have a supply of hydrogen gas, which is a fuel that's going to come in this way where my arrow is pointing to. Now, at the negative electrode, which is going to be the anode again, hydrogen molecules, they split into electrons and hydrogen ions. So here, where you can see my arrow going down, we have the hydrogen molecule, and this molecule is going to split into electrons and ions. Now, this splitting occurs from atoms to ions, resulting in a generation of 2 electrons. And these electrons are going up where the red arrow is on the left-hand side. So these electrons then travel to the positive electrode. So these electrons, which I'm going to circle over here, are going to travel to the positive electrode, which is the cathode. But how do they get there? So these electrons then travel to the positive electrode through an external wire. So you can see where the electrons are and the external wire. And that's going to be causing an electric current and releasing useful energy from the cell. Now, meanwhile, what else is going to be happening is that the hydrogen ions, which I've underlined right now, move through the electrolyte to the positive electrode, which is the cathode. So you can see these ions that I've just underlined now. They are going to basically move through the electrolyte to the positive electrode, where they will rejoin with these electrons to become atoms again over here. So they're going to rejoin with the electrons and they are basically going to become atoms again. Now, the hydrogen ions, I'm just going to change my color. The hydrogen ions also react with the electrons and with oxygen supplied to the cell, producing a molecule of water as a waste product. So water is going to be the waste product, which is going to go out that way over here where my arrow is pointing to in the red. And then obviously what's going to happen is that the hydrogen ions also react with the electrons and with oxygen supply to the cell, producing a molecule of water as a waste product. And that is it. That's all you need to know. What I've done at the end of the video, everything that I've explained, I've got it written down in a notes section. So if you want to use that information for your revision, you can definitely do that. Okay. So just remember, when it comes to hydrogen fuel cells, the anode and the cathode is going to be the negative terminal and the cathode is going to be the positive terminal. Please do not relate this to electrolysis. Just keep it separate in terms of your revision, okay? Now, what else you need to know about the hydrogen fuel cells is the advantages and disadvantages. So I've got all my advantages here and my disadvantages. Well, then one of the main advantages is going to be is that when we use hydrogen fuel cells, it just produces less pollution, as water is the only waste product. And then obviously, you know, the only downfall would be is that basically, well, there's quite a few downfalls, quite a few disadvantages, one of which I'm going to mention, which is going to be a few filling stations sell hydrogen. And hydrogen must be compressed and liquefied and then stored in tough insulated fuel tanks. Now, sometimes atmospheric pollution may be generated during the production of hydrogen. That is a disadvantage. That is a disadvantage. And obviously, the good thing about hydrogen fuel cells is that they are very efficient. The fuel cells last longer than conventional batteries that we use, and it's a direct energy transfer. I would advise you to have a read through these advantages and disadvantages. I've just zoomed in a little bit, and you can have a look at it in your own time. Right, the next thing that I am going to do is my half equations, okay? Now, I'm just going to quickly go back to this diagram over here, which I will explain to you at the very beginning. Now, where I mentioned at the negative electrode, which I'm going to colour in here, that's the negative electrode, which I've just coloured in red. The hydrogen molecule split into electrons and hydrogen ions. Okay, so hydrogen, this basically becomes ions. So we'll say that hydrogen has been oxidized. Okay, so this is where hydrogen has actually been oxidized. So the reaction that's going to take place over here at the anode is going to be oxidation. Okay, now I'm going to start the half equations on this page over here. So normally when we write up an oxidation reaction, the number of electrons always come after the arrows. But please just remember how I write up these equations is how you would need to do it for your exams. So here I have H2, that's hydrogen. Remember, it was a molecule first. Just remember, look back at this diagram. H2, it was a molecule to begin with, okay? And then what's going to happen is going to lose electrons, and then it becomes H plus. Remember, when they lose electrons, they become ions. And then the number of electrons that have been lost are going to come after the arrow, which we're going to work out over here. Right, I'm just going to change the thickness of my pen. Right, so first thing we need to do when we're writing up half equations, we need to balance it on both sides. So we've got 2 hydrogens there. And then what I'm going to do, I'm going to put a 2 over here. So there's 2 on the right. I'm going to put right there, left there, so you understand. Now, that's the first thing that we need to do when we're writing up half equations. We need to make sure it's balanced on each side. And then we need to look at basically the charge on each side. So we can see the charge on the right-hand side is going to be +2. You do the big 2 multiplied by the +1. And then there's going to be no charge over here. There's nothing there at the top. So that is going to be, oops, sorry, I'm just going to rewrite that again. Just one moment. I should have just undone it, sorry. Let me just undo it now. Okay, yeah. So that's got no charge over here where we have H2, so that's going to be basically 0, okay? Now, the rule is everything has to equal to the lowest number, which is going to be 0. So what do we do to +2? We do -2, and that's going to equal to 0. So it's going to be +2e minus. So this is going to be your half equation at the anode, okay? And just remember, hydrogen has been oxidized. Now we're going to write up the half equation at the cathode. This is a really difficult one over here. So at the cathode, we have oxygen gas. And do you just remember, when we look back at this diagram, we can see we have oxygen gas on the positive electrode, which is going to be the cathode. Yeah. So here we have oxygen gas, and basically we have hydrogen ions that are reacting with the oxygen gas. And what I'm going to do is I'm just going to show you this over here, how we write it up. So at the cathode, remember, it's going to be a reduction reaction because we're gaining electrons. Because remember, the hydrogen ions move through the electrolyte over here. They're moving through the electrolyte to the positive electrode, which is over here, where they rejoin with the electrons to become atoms again. So we say that they've gained electrons at this point over here that I've circled. So we have oxygen over here on the left-hand side, plus the number of electrons that have been gained. We're going to leave that blank. Oh, sorry, I'm going to put hydrogen actually here. Just one moment. So that's going to be H plus, and then the number of electrons that we have gained are going to come before the arrow. And then we have the waste product over here, which is going to be H2O. So let's firstly balance this, okay? So we've got 2 oxygens there, but we've only got 1 there, so I'm going to put a 2 over there. So there's 2 oxygens, okay? Now we've got 4 hydrogens here, but we only got 1 there, so I'm going to put a 4 over there. That's it, we've fully balanced it. Now let's look at the charges. So this oxygen that we have over here that I've underlined, that has got a 0 charge, nothing there. This has a charge of +4, and there's no charge over here. That's basically going to be 0, which is going to be for water. So what I'm going to do now is we need to work out the number of electrons that have been gained. So everything has to equal to the lowest number, which is going to be 0. So what do we do to +4? We -4. So that's going to be 4E minus. Okay, so this is going to be your half equation at the cathode. Now, we can work out the overall equation by combining these 2 equations together. And I'm going to show you exactly how you do that. So we're going to combine this equation and this one over here that I'm just underlining in black together. And I'll tell you one thing, it's not difficult, it's very simple. So what I'm going to do, I'm going to rewrite it over here again. H2 arrow, and I'm going to write 2H plus, and then I'm going to write down plus 2E minus. Okay, and now the next one I'm going to write is going to be O2 plus 4H plus 4E minus gives you 2H2O. Okay, now what we're going to do basically is we're going to combine both of these equations together. So we need to make sure that this has got 4 electrons, so they both need to have the same number of electrons on both sides. It's a bit like simultaneous equations. So what I'm going to do to make this equation over here, which is going to be number 1, just 1 minute, this is going to be number 1, and this is going to be number 2. So number 1 needs to be equal to number 2. It has to have 4 electrons. So what am I going to do on this side? I'm going to multiply it by 2. Okay, so what I'm going to do over here is I'm going to multiply it by 2. So on this side over here, I'm going to quickly show you what I'm going to do. So when you multiply it by 2, I'll get I'm going to use a different color. It would help use purple. So there'll be 2 there, and then that's going to be 4 there. I'm going to just get rid of that over here. That's going to be a 4. And then over here, we're going to have 4E minus over there. I'll just write that again. Okay, so that's going to be 4E minus, because I multiplied, obviously, it by 2 to make sure we have the same number of electrons on both equations. Now we need to cross out the reactants and the products that appear on both sides of the equation. So we just cancel them out. So here we can see we've got 4H plus there, 4H plus over here, cancel it out. 4E minus there, 4E minus here, cancel it out. Now we're going to rewrite the equation again. Okay, so that's what we're going to do next. And that's when we're going to combine both the equations together to get the final equation, which you may be asked to do in your exam. So let me do this quickly. So let's start over here with, I'll just start with, we've got O2 plus H2, and then over here we have 2H2O, and that is your final equation over here, and that is all you needed to do. Okay, right, I hope this makes sense on hydrogen fuel cells. Like I said, I will leave some information on the comment section, well, not the comment section, the description about as to what happens during the process. But this is everything that you need to know prior to your exam. And I really hope it has helped. If you do have any questions, do leave them behind in the comments. Now, I'm going to be going through some exam questions now. And I think the students specifically wanted me to go through these questions because I didn't understand them. Okay, now let's go through these questions over here. A student investigated simple cells using the apparatus shown in the figure below. Now it's got 3 bullet points here that we need to make sure that we need to make sure we read them and we understand them. So it says here, if metal 2 is more reactive than metal 1, then the voltage measured is positive. If metal 1 is more reactive than metal 2, then the voltage measured is going to be negative. The bigger the difference in reactivity of the two metals, the larger the volume produced. The students' results are shown in the table below over here. So these are all the results. I'm going to zoom in a little bit. So what is going to happen is, let's do the first question. The ionic equation for the reaction occurring at the zinc electrode in a simple cell made using copper and zinc electrodes is over here. So this is the equation. Now it's asking you in the question, zinc is oxidized in the reaction. Give a reason why this has been oxidized. It's because it's lost electrons. So that's all you have to write down. Lost electrons. Okay, next question. Look at the table above. Which one of the metals used was the least reactive? Give a reason for your answer. And that's going to be copper. Now, I think one of the students did say to me, is it going to be zinc? No, it's not going to be zinc. The reason it's going to be copper, because if you look at copper going down vertically over here, it's got two minus values, which I've circled. Over here, iron only has one minus value, which I'm going to circle in red. And then tin obviously has one minus value, which I'm going to circle in pink. So it's going to be obviously copper, because it obviously has the most minus values, okay? It has the most, negative volt. It has obviously the most negative voltage. So I'll write that down for you. Let me just do that now. Because it gave the most negative voltage. Most negative voltage when it was metal 2. Metal 2. Okay, so that's the most obvious answer that you would write down for this one here. You have to state when it was metal 2, because that's copper. When it's going across horizontally, it's metal 2. Okay, let's move on to the next question. Okay, so this one I've already got written out already. I've got some of the answer written out, but I'll explain this to you as thoroughly as I can. Predict the voltage that would be obtained for a simple cell that has iron as metal 2. So iron as metal 1 and copper as metal 2. So I know that basically iron is more reactive than copper. I know that already because I know the reactivity series. I know the order of the elements. So iron is definitely more reactive than copper. So it says over here, we can see that iron is metal 1, and it says here, if metal 1 is more reactive than metal 2, then the voltage measured is going to be negative. So it's definitely going to be a negative value. So just remember that part there. Right, okay. So what I'm going to do is I will go through the answer with you step by step. Now, we can see over here, we've got chromium over here, and we've got iron, and then we've got copper. Now, the voltage that is between chromium, let me just go into that part over here. So, between copper and chromium, it is 1.2 volts. So, between copper and chromium and copper, it's 1.2 volts, okay? Now, the difference between chromium and iron is going to be 0.5. So, we can clearly see that here. I'm going to just get rid of this over here. The difference between chromium and iron is going to be 0.5. Between chromium and copper, it's going to be 1.2. Okay, and then in red, we can see between chromium and iron, it's going to be 0.5. And I'm going to just put that over here on this example that I'm showing you. Now, so we know between chromium and copper, it's 1.2. So what is it going to be between iron and copper? So the difference between chromium and iron is 0.5. So the question is asking you the difference between iron and copper. So the difference between iron and copper is definitely going to be 0.7. Okay, because we know it's 1.2 from copper to chromium or chromium to copper. So that must be 0.7. But because metal 1 is more reactive than metal 2, it's going to be minus 0.7. And that's going to be your answer. And you have to give a full account of why. So you can write down over here well, it's pretty much shown on this diagram, but I'll write it down. The voltage with chromium one moment is 1.2. The voltage with chromium and copper is 1.2. And the voltage with chromium and iron is 0.5, and that will get you the full 3 marks. Okay, that's all you have to do. Just remember, copper is less reactive than iron. Okay, let's do a few more questions. I'm not going to be able to do all of these now. The video's been quite too long. Stay tuned for my next video that I do upload, but I'm not going to go through all of these questions now. It's going to take up too much time, but I will make another video on hydrogen fuel cells. But the most common questions that you're going to be asked based on hydrogen fuel cells are half equations. This diagram over here that I've gone through with you. And this rest of these questions, this one asks for it over here, write the word equation for the overall reaction that takes place in a hydrogen fuel cell. That's pretty much what I've just gone through with you. So I'll write it down anyway. It's going to be hydrogen plus oxygen, and it gives you water. And the two half equations, I've already told you what they are. Now, you'd have to write the half equations as what I've ticked over here. These are the two half equations they're looking for. If they ask you to combine them, then you do over here to get the overall equation. But these are the two half equations. This is the one at the anode. The one at the top is the anode. The one at the bottom, which is over here, at the cathode. Okay? And that will get you the full marks. These are the most obvious questions that you will be asked in your exam, hopefully, if they do come up. Okay, just going to go through question 2. Just going to do question 2, part of question 2, and then I'm going to finish off from there. Okay? What type of energy is released by hydrogen fuel cells? It's going to be electric green. Okay? And, hold on, I just put that in the wrong place. Let me just write it down. Okay, if you want to go through this paper to the end, please leave your comments below and I'll go through all the questions. But these are the most hardest questions that I've gone through with you at the moment, and I really hope it's helped you. Okay, thank you. Bye.